طيب بسم الله الرحمن الرحيم. السلام عليكم. Welcome to the Networks 2 course. I see some familiar faces, but most of the faces are new to me, so I'll have to introduce myself. My name is Amr Muhammad. I'm a professor here in the department since 2007. Before that, I studied my master's and PhD in University of British Columbia in Canada. I was responsible for the Cisco Academy here in the college, and this is my office information and my email address, and the TA is going to be Hiba Dawood again, and she will announce her office hours. My office hours for the male students is going to be in my office every Wednesday from the 12:30, so right after the lecture. If that time slot is not suitable for you, so you are free to send me an email and we can schedule an appointment which fits my schedule and your schedule. So this course, unlike Network 1, this course is going to focus mainly on the first three layers from the bottom. So physical layer, data link layer, and network layer. So we're not going to discuss anything related to transport and application layers. But we are going to cover these layers in great details, and most of the topics in Network 2 you will find it totally different from Network 1, although they build on the foundation and the basic concepts that you have studied in Network 1. So for the course description, again it describes the three aspects of the course, covering techniques in physical layer like encoding, like signaling for the physical layer. So we'll study some basics about signals, what are the different types of signals, and what are the characteristics that we use to describe a signal in the digital domain or in the analog domain. And then we'll study different techniques about signaling, digital transmission and analog transmission. Then we'll study data link layer aspects, which include, of course, logical link control. As we know, data link layer is divided into two sublayers, the logical link control and the medium access control. So we'll study different techniques in logical link control sublayer. So we'll talk about many techniques in logical link control. And then we'll, in the medium access control as well, we will study again in more details the medium access control techniques like contention-based and contention-free techniques in much more details in this course. Then the third part of the course, which is almost more than 30 or 35% of the course, is going to focus on dynamic routing protocol. This part is covered from CCNA 2. So dynamic routing protocol will focus on the protocols in the network layer. So we studied IP, of course. IP is mainly for addressing, but the dynamic routing protocols are required to route packets from one local network to a remote network, and we'll study many routing protocols like OSPF, routing information protocol, or REP, EIGRP, and we'll study these protocols in more details in this course. So these are the three basic or core aspects of the course. Excuse me, my voice is a bit off from recovering from a cold. So these are the course learning outcomes. Course learning outcomes, again, they are the first three outcomes. You will see them align with the three core aspects of the course. The first one, of course, is to discuss the basic principles of signals, digital and analog transmission, which are focusing on physical layer. Identify the concepts and techniques that involve data link, medium access control, and logical link control, which covers the data link layer part. And then identify the detailed characteristics of common dynamic routing protocols, which covers the third part. The last two learning outcomes, they focus on the practical part of the course. The practical part, in the practical part, you will go through some networking tools, and these networking tools are totally different from what you have learned in Network 1. So here, these networking tools are required to program something over the network, to implement some networking scenario. Okay, So we will be delivering 2 tutorials. I prepared 2 tutorials. One about socket programming, and I know that you have some familiarity in socket programming from object-oriented course, but you will get to exercise your understanding or your experience about socket programming in developing a client-server application in a sophisticated network scenario. Okay, which you may be actually going through as part of your senior project, and you are perfectly welcome to use your experience as part of the senior project towards developing your course project. The course project is what's detailed in the 5th and final learning outcome, where students will be asked to work in groups, okay, to develop a project that measures the performance of a complicated network scenario. So I will talk about it in details in a minute. This part is about mapping the course learning outcomes to 8-bit stuff, so I'm not talk about that much. So these are the basic topics covered in this course. So Introduction to Internet Protocol Suite, which we will cover today. So this is just a review or a refresher of Network 1. Okay, so we'll go through that today. And then these 3 parts, they cover the physical layer. So this is the physical layer. And of course, these 2, they cover the data link layer. Okay, and then the last part, which is the measure part, which will take about 2.5 weeks. This is the network layer. So these are the core parts or the core aspects of the course. There is an optional topic at the end, which students usually, they like to get some exposure to basics on security and cryptography, which I hope we will have time to go through as a last topic in the course. And usually this is just one lecture, in which we will talk about the basic concepts of security and cryptography. Okay. The most important part of the syllabus is the assessment criteria. And to me, going through the syllabus is very important, because this is the contract between the instructor and the students. So once we agree on all the terms in the syllabus, we will seal this contract, and then no one is allowed to change anything in this syllabus unless we have an agreement. So in terms of assessment, and it's a little bit short, so let me just try to, okay. So you will, the quizzes, we will have 4 quizzes, okay, which will constitute 20% of the overall grade. We will take the best 3, and again, I get this question over and over again. How many quizzes are you going to take, and so on? So this is in the syllabus, and it's recorded. And by the end of this lecture, it's going to be posted on YouTube. It's going to be available to you. So I don't get this question over and over again. So we will have 3 quizzes out of the 4. Best 3 out of 4. Well, so in which case, no quizzes will be repeated. Again, no quizzes will be repeated. So if you are absent in one quiz, okay, you will take 3 out of 4 anyway. I don't want to get a request from anyone to repeat any quiz. Okay, quizzes are not to be repeated. So if you have any strong excuses and stuff like that, we can use it in the midterm, although I don't like really repeating any exam, because you have to be aware that I prepare new exams every time. And the last thing I actually like is to prepare a makeup exam. I don't like that, really. I hate this. So do not. Chances are, even if you are not feeling very well in the midterm, it's much better for you to attend the first trial of the midterm. Much better than even if you feel very well and you attend the second trial. Let me put it this way. So it's really important for you to take this exam seriously, okay? and not try to waste the first trial of these exams. In any case, quizzes are not to be repeated under any circumstances, okay? So I'm talking about the midterm. Of course, the final is different. Final is handled by the college. There is a specific policy for this. Type. Midterm is 20%, final is 25%. So now we talk about the project. The project, again, students are asked to work on it in groups. And as far as I can see, there are about 20 students here. So we'll say maybe around 3 per group will be fine. Maybe 4, 3 or 4. Okay. In general, I prefer to have like 5 or 6 projects in each group. And the reason for this is that really I like to have constant interaction with each and every group. And that's why you cannot work on these projects individually. We cannot actually manage 20 different projects because each group will be allowed to select whatever topic they need to work on. Okay? The project is development based, so it's not survey. The project, you have to have a development component. You have to have a programming component. So even having, like, for example, Wireshark to see some packets moving around, that's not a project. Okay? Packet tracer is not going to help in this case. Okay? So you have to have either like a client server implementation or a simulation. Okay, one of these two. So you need to have one of these two directions. So client-server applications, you can build a program on a specific platform, whether this platform is a normal laptop, is a microcontroller, Raspberry Pi, things like that. And you can have like some kind of communication between 2 or more nodes. The most important component in the project is that you need to provide performance evaluation, which means that you need to study the performance of this network, for example, between different technologies, wireless technologies. For example, you can use Bluetooth, Wi-Fi in different frequencies, 4G, 5G, things like that. And then you measure the difference in performance between the different technologies, or between even wired and wireless, things like that. Okay? And in each networking technology or in each network setting, you need to measure the performance. And by performance here we mean what is the throughput, how the throughput actually changes from time to time, what is the delay, end-to-end delay, things like that. Okay? So that's for client-server implementation. And for that, of course, you heavily use socket programming. And that's why we will provide a tutorial about socket programming. Simulation is all about emulating a sophisticated network scenario in a virtual environment where you use a tool to build models of network nodes. And these network nodes, you set some configurations where they use specific protocols to communicate and a specific network medium. And that whole thing is going to be virtual. It's going to be running on a laptop, but you can actually run like 100 nodes communicating to each other on a virtual environment. So simulation tools help you to set up or to design a sophisticated network environment and then measure the performance of this network environment, again, using throughput, delay, and some other metrics. Okay? So, of course, for that part, you are allowed to use any a simulator out there. We will deliver a tutorial about Network Simulator 2, and the reason for NS2 is for the fact that it's widely available, open source, you can get it easily and so on, although it works on Linux or Unix environment, but it's very easy to get and download and set up and you get familiar with, and the tutorial is going to help you how to use it. So the project itself goes through 3 different phases. So you will have phase 1. Phase 1 is going to be a proposal, just a proposal. So I will give you like a project description with some list of potential topics. You are free to select even some topic which is different from the list, okay, even related to your senior project, things like that. And then you write a one page where you describe the proposal, what you want to talk about, what you want to, work on as part of the project, and what you are expected to deliver at the end, okay? Based on this proposal, I'm going to give you initial feedback. So the feedback could be good, go ahead, which means that, okay, your proposal is accepted as is, or maybe what you are proposing is very difficult to achieve. So you need to scope down your project a little bit. Or maybe this is very trivial, or it's not relevant to what we talked about. So you have to change. So we have to go back and forth, and then until the proposal is accepted. Once the proposal is accepted, students are encouraged to really start working on the project as soon as possible. The biggest mistake that students sometimes do is to wait until the end, until 1 or 2 weeks towards the end of the course, and then they start working on the project. And then they do not achieve really the objectives that they have set for themselves at the beginning, and then they get deducted some marks. Phase 2 is going to be probably after the midterm, okay? And in phase 2, you are requested to deliver everything except for the implementation. So all the detailed design, your architecture of the network that you want to study, what are the different technologies, what protocols, things like that, okay? Unlike the proposal, which is like one page, the phase 2 is going to be like 3-4 double column pages which describe detailed specification of what you are going to implement. Then I'm going to give you also some feedback about the write-up and so on. And then phase 3. Phase 3 is going to be preceded by presentation. So students will deliver a presentation which will summarize all the detailed design as well as the implementation that they have done. And sometimes, like after this, maybe 3 days after this, you will submit everything. Submit the presentation code and the project report and everything. And this will be phase 3, which is the final phase. Okay, so phase 2 is going to be detailed design, and phase 3 is going to cover the implementation in addition to the detailed design and everything. Okay? Any questions so far?
If there is any chance to change the percentages of those subparts?
It depends. What's your proposal?
Like, for example, it can decrease the weight for quizzes and increase it, for example, say, the projects.
I don't really advise increasing the percentage of the project. But if that's what everyone wants, we can talk about it. Like for some people, the practical part is usually tricky. So they are not really comfortable with the implementation, especially that here, remember, you are required to do some intensive coding. For some students, they are not comfortable really going through sophisticated development exercises like this. And if they don't really achieve well, they get deducted some marks. So for these types of students, maybe they won't agree with you. Maybe you are more comfortable doing some implementation, but I don't know if other students are, in agreement with this.
Sure. Even in the operating system, we just studied the basics of circuit programming. So we have no experience with...
True, yeah, and you will see that, yes, you will see that the circuit programming that you will use here, especially that circuit programming is going to be one part, but you are required to do performance evaluation. You want to measure the throughput. So you are not familiar with these things.
So it will be covered in the tutorial?
Yes.
Okay.
So So there are some challenges that you have to go through as part of the project, and some will not, be familiar with some of these things. So they need some learning curve, and that's why I always advise the students to start working on the project early. Once you have some idea what you are going to work on, and we agree as part of the proposal, you should start right away. You should not wait. Okay, and I actually expect that you use the office hour to report your progress every now and then. Okay? Any other questions? Okay, so that's all. I mean, the rest is like some standard stuff from the university, so talk about much.